It's Mr. Zanoni, and I am going to be going over our sign rules today. So, we're going to talk about our sign rules with working with negative numbers. So, addition rules are same signs add and keep sign, but that's only half of them. And different signs subtract and keep sign of larger absolute value. You need to memorize these rules. These are rules for negative numbers and they do not go away. So I'm going to go over some examples. So an example would be -2 plus -3. This one's negative, this one's negative. So same signs add and keep sign. Same signs add and keep sign. So 2 plus 3 is 5, but since it was negative, we keep the negative sign. And so my answer is going to be -5. Okay, now we're talking about different signs, subtract and keep sign of larger, keep sign of the larger absolute value. So here's example number 1. -7 plus 5. Okay, different signs, so 7 minus 5 equals 2. But the absolute value of -7 is greater than the absolute value of +5, so my answer is going to be negative. So this equals -2. We can see this on a number line. Okay, if I make a number line here, if I go to -7, and I can only add 5 back, I'm only going to go 1, 2, 3, 4, 5. And I'd graph my answer right here. Okay. Do I ever cross 0? No, I'm still in the negative numbers. So that's what this rule comes from. Okay. Okay, let's go over one more example. How about if I did 7 plus -5? Okay, different signs. So I'm going to subtract. 7 minus 5 equals 2. The absolute value of +7 is greater than the absolute value of -5, so my answer is positive. So this equals +2 this time. And again, we can see that if we draw a number line. Realizing I just set this up the wrong way, so I'll put 0 here. 1, 2, 3, 4, 5, 6, 7. So this is 7 here. So 0 to 7, and then I add -5, which means 1, 2, 3, 5. I would land here. Do I ever cross 0? With 0 being here? No, so it's still positive. Okay, so those are our addition rules. Now let's talk about our subtraction rules. So our subtraction rule is to change subtraction to add the opposite. Now this rule seems kind of weird, but let's say I had 7 minus 5, for example. I would change subtraction to adding -5. Subtraction becomes addition. 5 becomes its opposite, which is -5. Okay. We literally just did 7 plus negative 5 over here and got positive 2. And also, if I just had 7 apples and took 5 away, I would have 2 apples. So this rule does work. Now you might be wondering, why am I having you do this? This seems redundant. Well, in this case, yes, I go back to I change it, subtraction to add the opposite, and then follow rules for adding integers. And then I go over here. Okay. Now you're going to say, in this example, it's redundant because I would ask myself, same or different signs. Now that it's addition, I look at this. I ignore this now. This is useless. Now that this is addition, I now look at these two numbers. Same or different signs, so now I'm going to follow these rules, and now I have to subtract them. And you're probably like, wait, that's redundant. Well, there's also cases where I'm going to look at whatever I put down here, and I'm going to have to follow these rules up here instead. So just be mindful of that, and that's why we're doing this. Also, order doesn't matter with addition, but order matters with subtraction. So let's say I had 3 minus 4, for example. Can I just do 3 minus 4? If I stack them vertically, can I just do this? No, I can't, because I can't borrow if I do this. So instead, I'm going to change this to 3 plus negative 4. And this is going to say, oh, now it's an addition statement, follow the rules for it, different sign, subtract. So I can do 4 minus 3, which is 1. And I can do the absolute value of negative 4 is greater than the absolute value of 3. So I know my answer is negative. So I know my answer would be negative 1 to this question here. Let's go over the most obnoxious example of this. Okay, let's say I had 2 minus negative 3. We're going to change subtraction to add the opposite. 2, change subtraction to add. Since I changed subtraction to its inverse operation, change negative 3 to its opposite, which is positive 3. And then I follow my rules again for adding integers. Same signs, so I'm going to, same signs, add, and keep sign. 2 plus 3 is 5. Alright, we just have multiplication and division left. Luckily, these guys follow the same rules, so that should make our lives easier. So, if I have an odd number of negatives in the multiplication or division, my answer is going to be negative. Think about it this way. If someone walked up to you and called you odd, how would you feel about that? Probably not great. Or you might be indifferent, but probably not great. It's not a compliment exactly, right? So, let's talk about a few examples. So, the first example I have is negative. I have positive 3 times negative 6. Do I have an odd or even number of negatives? This number is not negative, but this number is negative. I have one number that is negative. So that means when I multiply these, my answer is going to be negative, and 3 times 6 is 18. Now, every time I multiply by a negative number on the number line, I'm flipping over 0. So for my first negative that I multiply or divide by flips me over 0 this way. So I go from the positive to the negatives. But then I flip back when I multiply by another one. So my pattern is 1 negative over here, 2 over here. If I don't have any negatives, right, I'd be over here. 0, 1, 2. If I multiply it again, I'd bounce back. So 3, then 4, then 5, then 6, then 7, and then 8, and then so on and so forth, right? These are all what type of numbers over here? These are all odd numbers. That's where the rule comes from. And these are all either 0 or even. Okay? So that's where this rule is going to come from. Now, I'm going to do another example just to show you. Let's do it with division this time, though. Let's say I had negative 24 divided by 8. Odd or even amount of negatives here. Well, this number is negative and this number is positive, so only one number is negative, so my answer is going to be negative. 24 divided by 8 is 3. And there you have it for that. Now I've got my last one. The other option is there is zero number of negatives, which makes it positive, or there's an even number of negatives, which makes it positive. Okay, so if there's no negatives in the multiplication or division, then it's just going to be a positive number. This is like any math you did before 7th grade. If there's an even number of negatives, it's going to be positive because it will bounce. It will flip once into the negatives and then flip back into the positives. So I'm going to go over -3 times -5. Okay, this is negative and this is negative. I have two numbers that are negative. I do not care about the value of the numbers. So a negative times a negative is positive. I only care about the value when I'm computing. 3 times 5 is 15. So -3 times -5 is 15 because I have two negative numbers that I'm multiplying. And then 3 times 5 is 15. Here's another example. I have -45 divided by -9. Again, I have one negative here, another negative here, so I have two negatives. Since I have two negatives, that's an even number of negatives, so my answer is going to be positive. 45 divided by 9 is 5. Positive 5. And again, I don't care about the values of 45 and 9 when I'm checking my signs. I only care about that for the computation. Well, thank you for watching, and these have been the rules for adding integers, subtracting integers, and multiplying and dividing integers. You need to know these rules to be successful in 7th grade math. Thank you for watching.